Hello everyone. Today's joke of the day is, what do cows read in the morning? Stay tuned to find out. Our learning target for today is, I can use the line of best fit from a scatter plot to predict a future outcome. So we can take a line and kind of fit it to the data presented in a scatter plot, and we call that the line of best fit. Basically the line that best represents all of the points there in the scatter plot. Okay, so we're going to think of it like the average of all the points. So let's look at the scatter plot here. We're going to take the time spent exercising and the calories burned, okay? And we're going to approximate the line of best fit. Okay, so we want to draw a line through all of these points that best represents all of those points. So kind of through the middle here. I'm going to say like that's pretty close to our line of best fit here. Okay, so we are just going to approximate it. This year we're not going to be asked to write an exact equation for the line of best fit, but you might be given an equation for the line of best fit and then asked to make predictions about the future based on that equation. Okay, so we're going to answer some questions and based on this scatter plot here, okay? So this plot shows the amount of time spent studying and the score on the test in Mr. Dillon's class, okay? So that's what this scatter plot shows. And we want to first draw in a line of best fit and kind of see, okay? Let's look probably something kind of close to this. Okay, that kind of looks like it's a good balance between all of the points. So that would be like our line of best fit there, okay? So an approximate equation for this line of best fit would be y equals 5x plus 50. Okay, and I say an approximate equation because there is an algorithm, a way to find the actual line of best fit, and it probably wouldn't have very nice numbers like this one does here. But I have approximated the line of best fit here, and that's the equation that we're going to use to just make some predictions and make some estimates, okay? For our purposes, it doesn't need to be very exact, okay? Just pretty close. So we're going to use this equation to approximate the percent that somebody got on their exam if they spent 4 hours studying, okay? Well, we know that our graph is, our horizontal axis is our x-axis, and then that's our vertical axis. So our independent variable, x, is going to be equal to the number of hours studied that a person studied, okay? And then y is going to be equal to the percent grade that the student earned. Okay? So if we know at 4 hours is what they spent studying, that's going to be an x equals 4. So we are going to substitute 4 into our equation for x. Okay, so we'll take y is equal to, remember that's the percent grade, 5 times the number of hours, which is 4, plus 50. So y is going to be equal to 5 times 4 is 20, plus 50. So y is equal to 70. 70%. We got to label that. So we are saying that a student would get approximately 70% on the exam if they spent 4 hours studying. Okay, let's see if that matches up with our line of best fit. So let's draw a line kind of up here. Just following the 4 along. Yeah, it's pretty close. This line of best fit maybe looks like it'd be like 74, 75. Okay, but pretty close there. Okay, so approximately 70%. That makes sense. If we put a dot here, kind of in the middle there, that could be a good dot to add to the scatter plot. It's not going to be like an outlier or something. All right, now let's see if somebody were to study for 20 hours, what do we think the score would be for their exam? Well, now this is x equals 20, so y is going to be equal to 5 times 20 plus 50. Okay, y equals 5 times 20 is 100 plus 50. Okay, so y equals 150%. So according to our equation, if someone were to study for 20 hours, they would score 150%. Now the next question says, is this reasonable? And we're going to have to say, no, this is not reasonable, because the highest percent they could get on the exam is 100, right? Unless there's some extra credit. But even then, if there was extra credit, there would not be that much extra credit to get 150%. So you'd say, no, this is not reasonable. You can't get higher. Oh, I forgot to write get in there. You can't earn more than 100% on an exam. Okay, not reasonable. So you always have to keep that in mind, whether or not something is reasonable, especially when you're working with word problems and approximations. Okay, so really if someone studied for 20 hours, it would be more likely that they would just get 100% on their exam. Okay, so you also might be given a percentage, okay? So you might be given the y value, right? Y equals 80%, and be asked to kind of do the opposite thing. Okay, so if someone scored an 80%, approximately how long would you predict that they studied for? Okay, so now we're kind of going to do the opposite. We're going to take 80 and substitute that in for y, and that's going to be equal to 5x plus 50. Okay, and now we just have to solve for x. Okay, so we'll subtract 50 from both sides. 80 minus 50 is 30, and those will cancel out, so we get 30 is equal to 5x. Divide by 5 on both sides, and then we know 30 divided by 5 is 6, so x is equal to 6 hours. So you would think that they would have studied for approximately 6 hours. Okay, so if you're given a line of best fit, just be careful that you know which variable you're looking for. Okay, as another hint, your independent variable, your x, is always going to be on the horizontal axis, and your y will always be on the vertical axis. Okay, so that the scatter plot itself can help you identify what those two variables are. Okay. All right, now for today's joke of the day. What do cows read in the morning? The moose paper. Thanks for watching and have a great day.